In this video, we will find the condition for a cone to have three mutually perpendicular generators. We'll also find the angle between the lines in which a plane cuts a cone. So a plane passing through the origin, and here the cone having three perpendicular generators are touching a plane. So conditions, if you are given different conditions, then how do we find the angle between the lines? So that kind of problem that we are going to discuss, and then we'll obtain the equation of the enveloping cone of a given sphere. So first problem, obtain the condition that the cone, this second degree homogeneous equation x, y, z has three mutually perpendicular generators. We would like to find the condition so that this one has three mutually perpendicular generators. In fact, we will be showing that this coefficient of x square plus coefficient of y square plus coefficient of z square, namely a plus b plus c, equal to 0. So that is the condition that we are going to arrive at. So how are we going to proceed? Now we'll just recall the angle between the lines in which the plane ux plus uy, ux plus vy plus wz equal to 0 cuts the cone. So this is the cone given to us. This is the cone that we have, and the plane we consider as ux plus vy plus wz. So both the cone as well as the plane pass through the origin, and these are the two lines at which the plane cuts the cone. Now we are given theta to be the angle between the lines, means then we have tan theta is given by this. We have tan theta being given by 2 plus or minus 2p. This is already derived. Plus or minus 2p square root of u square plus v square plus w square, where u, v, w are given here, and then in the denominator you have a plus b plus c into summation u square, that is u square plus v square plus w square minus f of u, v, w. So here this p is given in this way, that is capital P square is minus of capital A u square plus b v square plus c w square plus 2f v w plus 2g w u and plus 2h u v. Capital A, B, C, F, H, F, G, H are the cofactors of small a, small b, small c, small f, small g, small h in the determinant A, H, G, H, B, F, G, F, C. So this is known to us already. So we just borrow this result and proceed further. Now we are given that the plane cuts the cone in perpendicular generators. So that means the angle between these two, if it is theta, then this is the formula. Now if we have this theta to be 90 degrees, means you have tan 90, which means that is infinity, which means whatever you have in the denominator should be 0. So because this has two perpendicular generators, in fact 3, but we have we consider here 2, so because of that we have the denominator to be 0. So using theta equal to pi by 2 in 2, you get this. Now we have the third one, this generator. This is actually we have the line should have come here like this, you have. So it will be perpendicular too. So it is something like this. You have three lines which are perpendicular. So when you have this, the third one will also be on the, so you can imagine like this. The same thing. So you have like this. So that means this is what you have. And so you have this to be again perpendicular to this. So if we know u, v, w to be the dr's, origin being a point on the line, we can easily write out the equation of the normal. So how the equation of the normal is written? You have the dr's, u, v, w and a point. So if we know a point and dr's, we can write out the equations of line in 3D. So that is what you have this. So that is the equation of the normal. The normal line x by u equal to y by v equal to z by w equal to k, say to the plane is perpendicular to these two generators and is also a generator of the cone, and so this should be a point on the given cone. So that in turn gives that you can replace x, y, z by this, and being homogeneous equation you have that k square coming out. So f of k square into this equal to 0, k being non-zero, we have to have f of u v w to be 0. So in that f of u v w, if you replace that by 0, you are left with this, in which this is non-zero, and therefore a plus b plus c should be 0. So the condition that the cone to have three mutually perpendicular generators is that this a plus b plus c should be 0. That is coefficient of x square plus coefficient of y square plus coefficient of z square is 0. Coefficient of x square plus coefficient of y square plus coefficient of z square is 0. Now the second one, obtain the condition that the cone has three mutually perpendicular tangent planes. So here we are given the cone having three perpendicular tangent planes. So for this we need the help of we need the help of the reciprocal cone. Now if the cone ax square plus by square on this the given cone has three mutually perpendicular tangent planes means, then it's a reciprocal cone. See, given any cone we can find out the reciprocal cone. So we have the equation, that is what is the equation of the reciprocal cone? That is given by this. The equation of the reciprocal cone is this. This we have done already, where capital A, B, C, F, G, H, they are the cofactors of this determinant. They are the cofactors of these entries A, B, C, F, G, H in this. So you have all these are known to us already. So we have given the cone, we have written the equation of the reciprocal cone. Now what is known to us here? We have a cone which is touched by three perpendicular planes. Three perpendicular planes touch this cone. So that means when we consider, so we may have like this, then we may have one more like this, and another plane. So all of them are at right angles to each other, say. Then the normals, when we consider the normals, they will generate, that is the definition of reciprocal cone. So they will generate a cone that is called reciprocal cone. So we have the axis. See, when we consider the coordinate planes, the axis will be perpendicular. These are the coordinate axis, they are perpendicular. So these axes are generators for this cone. Now in the first problem we derived that whenever we have a cone having three mutually perpendicular generators, we have the equation for this cone as this. So in this we should have coefficient of x square plus coefficient of y square plus coefficient of z square to be 0. So that is what is given here. Now if the cone, this is the given cone, which is touched by three mutually perpendicular planes. So when we consider the normals, they will be the axis actually. So for this plane you have, see, when we consider this plane, this is normal. This is one of the coordinate axes. And when we consider this plane, we have this to be the normal to this plane, which is your y-axis. And when we consider this plane, we have this to be normal. So the coordinate axis will be generators for this cone, which is the reciprocal cone, and they are mutually perpendicular, and therefore having got the equation of this cone, for that cone only we should have coefficient of x square plus coefficient of y square plus coefficient of z square to be 0. So if the cone has 3 mutually perpendicular tangent planes, then its reciprocal will have 3 mutually perpendicular generators. Now if we have this equation having 3 mutually perpendicular generators, by the previous problem, coefficient of x square plus coefficient of y square plus coefficient of z square should be 0. So you have capital A plus B plus C to be 0, but capital A stands for this BC minus f square, and capital B is this. So you just substitute and then collect the terms containing quadratic expression and then the rest to the other side. So this is the condition for the reciprocal cone to have 3 perpendicular generators. Now, given the cone, the reciprocal cone will have 3 mutually perpendicular generators provided this condition is true, and given the same cone that will have 3 mutually perpendicular generators if small a plus small b plus small c is 0. So this is for the given cone, and this is for the reciprocal cone. But if we have the reciprocal as well as this one, the given cone, have 3 mutually perpendicular generators, then we have both this one to be true and also this one to be true. So based on this only we have the next problem. Show that if the cone, this is the given cone, and its reciprocal cone have 3 mutually perpendicular generators, then the coefficients A, B, C, F, G, H, they cannot all be real. So from the given condition, what is the condition given? Both the cone as well as its reciprocal have 3 perpendicular generators. So that is the given condition. So from the first problem, because the cone has 3 perpendicular generators, we have this. And from the second one, we conclude that the reciprocal cone has 3 perpendicular generators. So from that we arrived at this. So combining these two, if we consider a plus b plus c the whole square, this formula for this is known to us. In this, just replace your BC plus AC plus AB by f square plus g square plus h square. So this is what you have. Now, being the sum of positive numbers, we conclude that you cannot see, you have all of them to be positive. You cannot have all of them to be 0, definitely. So then they are all positive numbers. Then not all of them 0. Some of them can be 0. So but anyhow we have sum of positive numbers in either case. So we have this cannot be real. Sum of positive integers equal to 0 cannot be, it is not possible. So you have these, all of them cannot be real. Some of them should be imaginary. The next one, we find the angle between the lines given by ux plus vy plus wz equal to 0 and the cone. See, for the general cone, we know the angle between the lines. So this is known to us already. Right, we will start like this. Consider the plane. The given plane is this. The cone is given by this. Now for the general case, we know what is the angle between the, see, we have a cone. This is the cone generally when we consider, and this is cut by a plane. This is cut by a plane means we have these two lines. These two lines that we have, and the angle between them, this is known to us already. So that's given by tan theta, and p is given by p square rather, that's given by plus or minus all that that is given by minus that a u square that we will see. we have already seen, and here it is. Such a big expression. P square is minus of AU square plus BV square plus TW square plus 2FVW plus 2GWV, U plus 2HUV. So that is tan theta in general for a given cone and a plane is known. But here the cone equation is this, in which you don't have x square term, y square term, z square term. So in that case, what is your tan theta? So that is what, I mean, theta is tan inverse of whatever expression that we have. So tan theta we are trying to find. For the general case we know, in this case we have the equation to be particularly in this form, equation of the cone we have in this form. So in such case, what will be tan theta? So you consider the plane, name that as equation 1, and the given cone, given equation of the plane and the cone are named as 1 and 2. Then compare 2 with the general equation. So you get what is A prime, B prime and C prime. So you have what is A prime, what is B prime and what is C prime. They are all zeros. And when comparing these two, 2F prime is F, so F prime is F by 2, and in the same way G prime and H prime. So this is known to us already. If theta is the angle between the lines in which the plane 1 cuts the cone, that is already, this is a borrowed result. So you have this cuts the cone, then we have tan theta to be this. Now where P stands for, already it is mentioned. Capital A, B, C, they are nothing but the cofactors of small a, b, c, f, c, h from this determinant. So you have, now we are going to use 4 in 6 and 7. What is 4? You have A prime, you have, if theta is the angle between the lines in which the plane cuts the cone, we have this. This is equation 4. This A prime, B prime, C prime and all you are substituting. They are all 0 and F prime, G prime, H prime. So you have the values being given, I mean they are substituted here, and you have capital A to be this, B, C, G, F, G, H. So capital P square, which is nothing but this, you are just substituting those values here, you get this equation, name that as 8. And in the denominator we have this, so that is also simplified in this way. So the numerator you have plus or minus 2p square root of where p square is given by this, u square plus v square square root of u square plus v square plus w square, and the denominator now reduces to just this. So this is the tan theta that we are getting if we have particular case. Okay, so next we have another problem that is the same. I mean this one we have just the similar to that of the previous one. There we had f. There we had f of fyz plus gzx plus hxy, and then here we had ux plus uvy plus wz. So that is the only difference, but the procedure is the same. So what we do, you name this as equation 1 and this as equation 2. Comparing 1 with this and 2 with the standard one, we get the values of u, v, w, and a prime, b prime, c prime also we have obtained, and f, g, h, they are also given. Now if theta is the angle between the lines in which the plane cuts the cone, then tan theta is given by this, and where this p square stands for this, where capital A, B, C, this involves A, B, C, F, G, H, they are given by this one, that is they are the cofactors, and we are substituting u equal to 1, v equal to 1, w equal to 1 and all this, And so when we do so, ultimately we get our P, which is this is your P. So you are substituting U is 1. U is 1. See, you have like this. U is 1. So you have, this is actually P square. P square is, P square you have as P square is minus of AU square. What is A? It is B prime C prime, but B prime C prime is this minus F square. Minus F square means minus of 1 by B minus C the whole square. And in the same way, you don't have this one B V square. B in this is not there, so minus G square you'll have, but minus G square is minus of 1 by C minus A the whole square. So in all you will have that negative sign. Already here you have negative sign, so that is why P square is just written with this plus sign. So we have in fact we have this to be once again. When we consider this, you have P square. P, when we consider, this is 2F is equal to, see here it is 2F is equal to, when you compare 1 by B minus C, so that means F is 1 by 2. So here it is F is 1 by 2 B minus C. This is 2. So this is what we have. So that is when substituted here, it all needs correction. This is 2 times B minus C, 2 times C minus A, 2 times A minus B, which means that 4 will be there in all. So here it is 1 by 4 P square. If you are writing P means 1 by 2, the whole thing to the power half you will have. So and then in the denominator we have A prime plus B prime plus C prime. This is A prime plus B prime plus C prime. So that is 0. So you will be left with only this. And f of UVW is, what is f of XYZ? You have f of XYZ to be, you have this to be f of XYZ, this one, f of XYZ. So when you consider f of UVW, it will be U and V and W, they are each one is equal to 1. So you will have 1 by B minus C plus 1 by C minus A plus 1 by A minus B. So that is what is written in the place of f of UVW. So this is 0, and in the place of this is what you have. So you have got in the numerator, you have this to be 1 square plus 1 square plus 1 square, that is root 3 you will have. And P square value you have, so taking the square root you have this, and substituting this numerator and denominator we are substituting, and this is what we get. So you have theta to be tan inverse of this. Acute angle is considered, so you have only this. Now this is the case when you have FGH to be 1 by B minus C, 1 by C minus A, 1 by A minus B. Now show that the angle between the lines given by x plus y plus z equal to 0, and this one is equal to 0 is pi by 2 if f plus g plus h is equal to 0, and pi by 3 if this is true. So we do this with the help of the fourth problem. We do this problem with the help of the fourth one. So there we have already derived, if these two are given, in fact there we were given ux plus uy plus vz. ux plus vy plus wz equal to 0. So in this case, that u here u equal to v equal to w equal to 1. So in this case, u is equal to v is equal to w is equal to 1. So when you substitute that, you get plus or minus 2p square root of 3. These being 1, you have, this is what you have. Now in this, determine what is p. P is nothing but half into square root of, we have from here p square. This is from the fourth problem, that all this we have, and this is further simplified. This is further simplified in this way, because your this f square by 4, when you take 1 by 4 out, this is what you get. So p will be half into square root of all this. So tan theta, this is known to us, in that we are replacing UVW by 1, so you get this. Now if we have theta to be pi by 2, then whatever we have in the denominator, that should be 0. Tan 90 infinity, so you have to have this to be 0. So you have got the first condition. Now suppose you have theta to be pi by 3, say, then tan pi by 3 being root 3, in this you can cancel these two, so you will be left with f plus g plus h the whole square, and this is you have 4 times p square. So you have, when you have 4 times p square is already given in this. So 4 times p square means you have just these terms alone. So that is what is written here. And this is, so when you expand this out, when you expand the left side, this is what you get, f square plus g square plus h square plus 2fg plus 2gh plus 2fh is equal to, the right side you have this. So these will get cancelled with these terms. You are left with this, and on the left side you have this. So you have 4 times. So this on simplification gives you 4 times fg plus gh plus fh equal to 0, or in other words, fg plus gh plus fh 0. You divide throughout by fgh, so that you will have 1 by h plus 1 by f plus 1 by g equal to 0. So that is the condition that is required here. So you have, when it is pi by 3, you have this. So it is just the continuation of the sixth one, and fourth one, when you do the fourth problem first, then you have automatically this one, and then even the next, this problem, instead of fgh, you have 1 by 2 into b minus c, 1 by 2. So you just substitute at once, the tan theta can be easily obtained. Now we'll find the angle between the lines of the section of the plane with the cone. Again you have the cone being cut by a plane, so that you have the angle. These are the two lines that we have, this one and this one, common to both the plane as well as the cone. So if theta is the angle between them, then we know already that tan theta is given by this is the plane equation and this is the cone equation. If that is the case, then from the general we have reduced the problem to this one. So from the general case we have come to this level. So your tan theta will be this, and your p square will be like this. Now you compare this with, you're comparing this 3x, this one, with ux plus vy plus wz equal to 0. So when you compare it, you will get u value to be 3, u is 3, so you have, and then v is 1, and w is 5. So that is what we have, and then you will have to compare this equation. You have to compare this equation with this, so that you get f to be 6 and g to be minus 2, h to be this. So what we do is we consider our p square. P square is given by this. In that, just substitute the values of f, g, h. Substitute the values of f, g, h, u, v, w. Then simplify that. You will get p square as this, 225 divided by 4. So p is 15 by 2. So that is as far capital P in the numerator is concerned. Now coming to this one, u square, square root of u square plus v square plus w square, you have that to be 3 square plus 1 square plus 5 square. So you have that to be 35, square root of 35. P is this. Square root of u square plus v square plus w square is this. In the numerator, we have computed these two. Now coming to the denominator, you have just substitute the values of FGH, UVW, you get this. 13, this is plus 15. Plus 15, and that is equal to 15. So you have tan theta to be, just substitute the values. So this is 15 by 2. Already here you have 2, so you have this. You can cancel out this 15, giving this. So with the positive value being considered, acute angle being considered, so we have this. So theta is tan inverse of square root of 35. So this is how we find the angle for the given UVW in this way. This is how we. So that is the reason why for the general case we derive, and then using that as a formula, we can do any number of problems. Now, enveloping cone of the sphere. You are given the sphere, and we have already obtained the equation of the enveloping cone as this. You have when you consider the enveloping cone given a sphere, then you have the equation. So this is done already. You're drawing the tangent from the sphere, and then you have the equation to be t square is equal to ss1, where t is nothing but the tangent to the equation of the tangent plane to this tangent to sphere. So if we have x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0 to be the given equation of the sphere, the tangent at x1 y1 z1 is given by xx1 plus yy1 plus zz1 plus this is u into x plus x1 plus v into y plus y1 plus w into z plus z1 equal to 0. So it is for t that we use this, and here you have u to be, just compare this with this. So 2u is minus 2, therefore u is equal to minus 1, and 2v is 0, so v is equal to 0, and 2w is equal to 4, therefore w is 2. So that is what is used here, xx1. So in the place of xx1, x1 is 1 here, x1 is this, y1 and z1. So the point is given to us, so just substitute, you get this, and s is just the given sphere that we have to have as such. S1 means the s at the given point 1 1 1, and that we are getting as 4. So the equation of the enveloping cone of the sphere, we know that t square is equal to ss1 to be the equation. This is derived already. This is derived already. So you have just we can make use of that. So we have in the place of t just this y plus 3z, substitute, and then s1 is 4 and this is your s. On simplification you get this. So like this, given any sphere and the vertex of the cone, we can easily find out the equation of the enveloping cone. Thank you.